Okay, so this drill then. First question, factorise 5x plus 10y. Factorise means look for common elements in the terms. So remember, these are terms, that's one term, that's another term. So there's two terms in this expression. That's an element, so 5 and x are elements, 10 and y are elements. Common elements. Is there a number or a letter that's common to both of those? 5, right. So we can take 5 outside the bracket. Now you ask yourself the question, what's left inside the bracket? You multiply 5. What have I got to multiply 5 by to get back to 5x? Answer? X. What have I got to multiply 5 by to get back to 10y? 2y. So if you got that, well done. That's factorising, removing common elements from the expression. Number 2, 2/3 plus a quarter. The key here is to find the common denominator, which in this case would be 12, right. So I want to turn them both into 12ths. How do I get the common denominator? Certainly in algebra, I multiply the numbers together. 3 times 4 gives 12. So that's an easy way to find a common denominator. Okay, there might be a smaller one sometimes, but certainly 12 will do it. So now I ask myself the question, right, I've got to turn thirds into 12ths, so I've got to times by 4. So what have I got to do to the top? Times by 4. 2 4s are 8. Same with this one. I've got to turn fourths into 12ths, so I times by 3. Do the same to the top. 3 1s are 3. So I end up with 8 12ths plus 3 12ths. Not the sort of thing you're going to be asked to do regularly in maths or in the engineering, but when it comes to algebra, similar sort of questions arise when you're adding fractions algebraically. So you need to know this skill. Common denominator. Then it's easy. We don't add the bottom, that's just what we're adding, so that's 12ths. Add the top, 8 plus 3 is 11. So if you got that, well done. I'm going to move rapidly through, but if you're not sure or you want to make a comment, just say, okay? Number 3, calculator question. The reason why we try and do it in one hit is because it holds all the accuracy in the calculator, and then at the end you round to whatever accuracy you want. Every time you round a number, you're reducing the accuracy of the final answer. So the more things you have to do at a bit at a time and write down the answer of, the worse your answer is going to be. So the calculator is able to do this in one hit, and it's worth learning how to do it. So what do? We hit the square root button. And then if you look at your calculator, you've got a button that looks a bit like this, this fraction button. I think we probably mentioned this already. The fraction button, use that. If you hit that, you'll see this line appear in the calculator and then a flashing cursor above, so you can go above and below. So I'm now going to type in 15.62, and then I'm going to hit the x squared button, and that will give me 15.62 squared. So I hit the x squared button, and then I get 15.62 squared. Underneath, 29.21 times square root, so I hit the square root button again, 10.53. And if I look at the calculator on my screen, it will look exactly like what I've got on a piece of paper if you've got these sort of calculators. And then once I've done that, I hit equals, and I get the answer, which is, somebody? What does it say?
1.6.
Sorry, 1.6? Right, 1.604 and a few more. What's an appropriate accuracy? Yeah, you've got 4 significant figures there, 4 there, so 4 significant figures, so 1.604, is that right? Yeah, so 1.604 to 4 significant figures would be good. So if you got that, well done, okay? If you're not sure about how to put those numbers into the calculator, practice with your calculation. If you don't have a calculator, buy one. Okay. Next, number 4, area of a circle. So formula for the area of a circle, pi r squared. We need to know that. So all I've got to do is key into the calculator pi, hit the pi button, times by r, which is half of the diameter, 25 squared. And then equals. And what do you get? 62.8 unit. Good. And you presumably rounded that, have you? So 3 significant figures. Okay? So know that formula, please. The area of a circle is pi r squared. And don't forget, if you're given the diameter, that the radius is half that. Yeah. 1963. Yeah, right. Actually, that looks reasonable. If you think the 25 squared, it's going to be quite a big number, isn't it? So 1963. 0.495. Anybody else get that? Right. I should have looked at this, and that's a good. Oh, did you? Okay, so that's where you went wrong. Fair enough. But think about 25 times 25, big number. So actually, if I'd have thought about it, I'd have realised that was wrong. Okay. That's not an appropriate accuracy, though. We've got 7 significant figures there. So what would we do with that? To what? How many? 5. 5 is okay, but not more than 5. So it's the same or one more. So 4 or 5. I'll probably go to 4, as that's a whole number. 1963 square millimeters. Yeah. So 1963.5 would be fine, or 19. I see what you're saying, but because it's a 4, that's the only one we consider. I hear what you're saying, but because it's a 4, that's got to go down. Okay? Number 5. Anybody know the formula to find the density of something? We haven't talked about this, but does anyone know it? Not times. Must be divide then, mustn't it? Density of a material is the mass divided by the volume. Mass per unit volume. So, anybody know a unit for density? For materials, have you used it at all in your materials work? Grams per cubic centimetre or kilograms per cubic metre are 2 accepted forms, units rather, for density. And they give you the formula. Grams per cubic centimetre or kilograms per cubic metre. So if you remember the unit, you've got the formula. Now, look at the question. What's wrong with the numbers I'm given in terms of what we've just been talking about and units? Yeah, we've got kilograms and cubic centimetres, so we've got mixed units. So I either need to convert the kilograms to grams and then give my answer in grams per cubic centimetre, or convert the cubic centimetres to cubic metres and then give it in kilograms per cubic metre. Much easier to go from kilograms to grams. So what's 2.462 kilograms in grams? Right. So I'm going to type into my calculator 2,462 divided by 173 to get divided by 173 equals, I'm turning it on. What's the answer? What, 2? Round to an appropriate accuracy. 14.23 grams per cubic centimetre to 4 significant figures. There's a lot in that. If you got the right formula and you've got kilograms over cubic centimeters, give yourself the mark. But bear in mind from now on, please, that density is measured in either grams per cubic centimetre or kilograms per cubic metre. You don't mix them up. And I think you need to remember that formula. Certainly in materials, we often find densities of materials. Or given the density, find the mass. So we rearrange the formula to find the mass of something. That's very common. If I want to know how big or how massive a steel girder is going to be before I load it up, before I hire a truck to carry it somewhere, how do I calculate the mass? I use this formula because I can look up somewhere the density of the steel, rearrange this formula to find mass, and then it turns out I have to multiply the density by the volume to get the mass. So I can predict what the mass of my steel girder is going to be before I get it delivered. So we use this formula all the time. Remember it. Averages. Mean. What do you do? To find the mean of a number of a load of numbers. Yeah, exactly right. Add all the numbers together, which is called the sum of fx. So you might see this formula, I've seen it already if you've started looking at those exercises, divided by the sum of the frequencies. And that's saying, arithmetically, add the numbers and divide by the number of numbers, the frequency. And that's it written arithmetically. So if you see that formula, that's what it means. This symbol here means sum of. And I'm sure a lot of you have seen that symbol before. Mode? The most common, yes. Median? Correct. That's correct. Yep, middle, put in order. Obviously, there's no point finding the middle if they're not in order, so you put them in order of size, and then you find the middle value, and that's the median. Final question. Rearrange Ohm's law for current. Anybody remember Ohm's law? V equals IR. How do I rearrange that for current? I equals V over R, yes. What I do is, and this is leading into something we may touch on today, I have to make I the subject. So focusing in now on this question, please, okay? I've got a formula here. The left and the right-hand side are equal to each other. So V equals IR, an obvious statement. In algebra, if I've got something like this with an equal sign in the middle, I can do anything I like to one side, so long as I do the same to the other. So I could add something, some constant, to that side, so long as I add it to the other side, that's fine. I can multiply this side by something, multiplied by P, multiplied by P, or, and I can do that so long as I multiply this side by P, okay, etc. So what I do is I look at this right-hand side and I say, I only want I, so I want to get rid of R. How do I get rid of R? I divide by R, so that they cancel out and I'm left with just I. If I divide this side by R, I must divide this side by R. So therefore, I equals V over R. We use the rules of algebra to rearrange formulae to make what we want to find the subject. And that's a simple example. We'll have to do more of that sort of thing. Okay? Okay. Tot up your marks and then pass it along to the end of the bench that end.